Next thing, I guess, would be, hey, your test is tomorrow. Okay, so tomorrow's an asynchronous day. I talked to you guys about this on Thursday. You either there's no regular class that day tomorrow. Log in at 10 or log in at 1, take your test, one of those two times. Okay. If you have any problems with that, you need to send me a message privately send me an email. Okay. Um, so let's use today. Let's go over it. I did this morning. I think it worked really, really well. I had a lot of people either in class or on Zoom, and we knocked out the entire review in like 30 minutes. Okay, do you guys want to do a lot of this review together? Sound good? All right. If you haven't noticed already, go into Schoology. You don't need to pull this up right now, but for those of you that haven't come, hopefully you see I already posted an answer key to the review. So you can actually check your work. Don't just copy. If you copy it for a free 100, that's not going to be good enough. I mean, that 100 is not going to do anything to your grade as a good grade on the test is going to be. So check your work. Use it to check your work. But let's go over some of this, or maybe all of the practice problems. I did this earlier with the first class. Practice problems. Get out your journal. Get out a blank piece of paper. Doesn't matter where you put it. Jocelyn, you too, so that you can get all these. And if you guys turn this in, I'll give you a free daily grade, completion grade, to help out with some of your grades. Okay. After we're done, I can go over any missing grades that you guys have. Here's a copy of it for those of you that don't have it if you need it. You guys at home good with going over some of this stuff, and I'll start taking roll for you guys. Don't log off yet because I haven't taken roll yet. Let's start. I'm going to skip 1 through 10 because that's part of your study guide. You can find the answers in those notes. Number 3, watch this short video real quick to answer these questions. These questions are just straight from that video. That'll get you prepared for that section. But let's go over the practice stuff, and we can knock out 11 through 16 super fast. So here's a graph that I got. It says Roy was doing a research paper. He questioned students throughout his high school, asking them how much time they spent doing homework and how much time they spent watching TV the previous evening, so last night. The following scatter plot shows his results. Number 11, describe the correlation of the graph. How strong do we want to say this is? Relatively strong, all right? We can still see a pattern, so I would still say relatively strong. Good. So it's relatively strong. Which direction? Negative. And linear or something else? It looks pretty linear to me. Okay. So it's a relatively strong negative linear correlation. Boom. There's the answer to number 11. Number 12, interpret the information. This is a question that a lot of people missed a lot on their quiz and their homeworks as I've been grading them. Interpret means, what are we learning from the graph? What is the graph telling us? In general, the longer the student spends watching TV, what happens? The lower, the less amount of time they spend doing homework. Yeah. The longer they spend watching TV, the lower the amount of time they spend doing homework. There's your answer to number 12. So for questions 13 through 15, all you're going to do is match the saying there, the quote, with the correct letter A, B, or C, actually. You see A, B, C, the dots on the scatter plot. Well, each of those is going to match up to one of those quotes. Number 13 says, last night there wasn't anything on TV that I wanted to watch, and my homework was so light that I ended up going out and hanging out with friends. Which letter would best represent that, A, B, or C? Very little TV, very little homework. Outlier? Like B? B? Yeah. B is closest to 0 on both X and the Y axis. That's correct. B would be the best one for number 13, where you didn't watch very much TV, didn't do very much homework. You just put B. You don't need to write anything else. Number 14. I worked on homework almost all night. I only had time to watch my favorite sitcom. A, yeah. Did mostly a lot of homework, 3 hours of homework here, but very little TV. And 15, the Bachelor 3 hour finale was on last night, so I only did a little bit of my homework. That's you, Alyssa, right there. You watch Bachelor? Yeah, I do. Do you? I do. So you're C right there, right? Because you watched a lot of TV last night, but not not a lot of your homework. Now, write me something for number 16. What could you say about letter D? What would be a good quote about letter D? There you go. Yeah, I did my homework while I was watching a couple movies last night. Or what? Sociopath? Y'all don't watch TV while you're doing homework? You can't. I know. It's hard. It's hard for me to too. Like I will focus more on the work that I'm doing than I am on the show. Yeah, people like listening to music while reading or something. What is 16? It says write a statement that could be used for point D. Like D, if you look at D, it's a lot of TV and a lot of homework, right? So you could say something like I was doing my homework while I was watching TV last night. I can't do that with shows because I can't pay attention to the show. But like if there's a game on, like a football game or something, sports, I can watch that while I'm doing work. Easy. This stuff is not hard. Stuff's not hard. Now, on the test, you guys will have one set of data that you'll have to put into the Desmos calculator. Does everybody know how to put data into the calculator? Okay. You're gonna link. I'm gonna have a link to the calculator. This specific calculator, actually, for you to pick your best data set. Make sure you know how to do this. Let's do this together. Go ahead and if you have a chance, open up this particular Desmos calculator that I have on the top of page 2, and let's do it. I did all of these with last period, and that's fine. I can do them all if you guys want to, but let's at least do the very first section where it has a statistics class wanted to determine if there was a correlation between fat grams and total calories. They use the following data to help them, and here's the data right here. So go to the Desmos calculator, and I will also put this in with you guys so you can see what it looks like. And I'm going to finish taking roll while you guys are doing that. Here I just lose. Don't forget, and this is a lot of people made this mistake too on their homeworks and their projects. Don't forget to zoom in. This little this magnifying glass right here will make sure that you zoom into the data perfectly. So you click that once to make sure to show you to zoom in. Then you can answer the questions from there. So question number 17 just says sketch a scatter plot. Guys, don't spend more than like 30 seconds sketching that. Just do a rough sketch so you see the pattern, see the shape. There it is right there to look and see if you did it best.
Oh yeah.
You can do it wherever. It doesn't matter. If you can fit it there, fit it there. I'm not concerned about that at this point. Just easier for you guys to see. There's no stipulations. If you do it and you show it looks like you did it, I'm going to give you a free 100 for it. Okay. So number 18, interpret the graph. What are we learning from this graph? Don't forget these are sandwiches that show fat and calories. Remember, fat is on this side.
The more grams of fat, the higher the calories.
Yeah, more grams of fat, the higher the calories in the sandwiches. And I think if you know anything about nutrition, I think that's just goes without saying. More fat, more calories. So on number 19, which equation works best? And I'm only giving you two choices here, linear or exponential, because it's not any of the other ones. What does it look like? What do you think, linear or exponential? Is there a curve in that graph? Is it like curving upwards or downwards? No.
Linear.
Yeah, I would say it's mostly linear. There's a couple of reasons. One, look at the correlation coefficient for the linear, 0.9746. That's pretty freaking strong because it's pretty close to 1. So that's one reason. The other reason is it's mostly a straight line. Okay, it's not curved at all. The straight line you can use the feature there. That's going to be the best fit for the data. So for number 20, it says to write the equation for that function. So we're picking linear. This will pop up. Thank you. And I'll just go ahead and do it right here so you guys can see it. So number 20, write the equation. The information is here on the screen for you. It says round to the nearest hundredth, the number to the nearest hundredth. So y equals, so mx plus b, m is 11.73, x plus b is 193.85. And there's your answer to number 20. Pretty easy. Super easy. 21. It says, use your equation, find the number of calories for a Whopper from Burger King, which has 37 grams of fat. 37 grams of fat. Is that going to get plugged into Y or to X? X. Fat is on the x-axis. Fat is in the first one. 37 is it. So here's how I'm going to set it up. 11.73 times 37. plus 193.85, and then I'm going to type that into the calculator to get my answer. I'm not going to do that. Y'all are going to have to do that on your own. Figure out what that is. I think somebody's having connection problems. What'd you get?
I got 627.86.
86 grams of fat. Boom. These are easy problems, guys. Easy problems. We do the last one in that section, 22. 22 says, use the equation, find the number of grams of fat for a baconator, which has a total of 930 calories. So what are we plugging in 930 for this time? For Y. So here's how I'm going to set it up. Got to solve for X now. I have some over there too. Awesome. You're right there. Alyssa, what do I do first to solve for X? Not divide yet. Subtract what? 193.85 from both sides. This will cancel out. Y'all need to tell me what that is. What is that? Anybody at home want to give me the answer? Anybody? What'd you get, Alyssa? So 930 minus 193.85? Try it again. What'd you get?
Oh, 736.15.
What'd you get? Oh, because you did 193 minus 930. Yeah. Other way around. Yep. 1.73x. Now what do we do? What did you just tell me a second ago? Now we're going to divide. Yeah. Divide both sides by 11.73 because that's the number that's in front of x. That cancels out. So x is going to equal 72 point what? 75.
75.
Wait. 62. 62.76.
Can I get a pizza point for correcting myself?
That's grams of fat. This is calories over here.
That's what I was just about to say.
Yeah. Thanks. Gotta take a pizza point away from you guys.
Whoa.
Yeah. So this should be calories up here, and then grams of fat down here.
Just put it on the record. I corrected myself.
Okay. Yeah. Easy. It's not hard. This stuff's not hard, guys. This is not hard. I'm trying to make this test as easy as possible for you, but you got to just know what you're doing. All right. Should we do the next section together? Go ahead. Let's do the easiest way to refresh this is just to refresh the browser. If you refresh the browser, it'll clear out the table and you can start over. So the rest of these tables are a little bit smaller. The next two are pretty small. Let's knock them out. Let's get you guys everybody here today, a free 100. Go back and do those, and then we'll talk about what you guys are missing. So we're on question number 23. The population of single-celled organisms is grown in a petri dish over a period of 16 hours. Number of organisms at a given time is recorded in the table. So put that information into the table and make sure to zoom in. Don't forget to zoom in. All right. Well, 23 should be pretty straightforward. What about 24? Describe the correlation. How strong is this? That's pretty strong, really strong. You can see a pattern there. It's very strong. Is it positive or negative? Positive. Exponential correlation. Yeah, I would not call that linear. I mean, you can use this to even check it out. Look how here's the line on top of the graph. Definitely not a good fit, but the exponential line is going to be way better. And you can see it right there. Okay. So a very strong positive exponential correlation. As far as number 25, write the equation. I'll scroll down here. There's the information right there that you need in order to write your equation. It does say to round to the nearest hundredth, so that's what I'll do that too with you guys. See if you can write it down on your own. 25 y equals A is 26.84. B is 1.15. And then don't forget to write to the power of x up there at the top. A lot of people on their homeworks forgot to write that. Okay, don't forget to write that there. Oh, easy. 26, use the equation. Find the number of organisms that will be present after 48 hours. Hours is x. What are we going to do with 48? Plug it in for x. Pretty easy. So set it up like this. Y is equal to 26.84 times 1.15 to the power of 48. So we're going to put 48 in here. That's yeah. Type it into your calculator. The number is going to be really, really, really big. Don't be scared if you get a big number. When you're dealing with exponential, you're going to get big numbers. How about somebody from home tell me what they get? Let me put that in the calculator. See if they're paying attention.
I got 21,992.71.
Good. There you go. Perfect. On the money. Was that Leslie?
No, it was Miranda.
Miranda? Oh, sorry. I can't see it. Everything's hidden right now. Thanks, Miranda. All right, y'all want to do the next section? Let's do the next section. Refresh. Knock this. We're almost done. Ooh. So this one shows the average height for males in the U.S. at different ages in 2012. And the height is in inches. So X is the age, and the height is in inches. Zoom in. There's a scatter plot you can sketch. Don't, like I said, don't spend more than like 30 seconds drawing that. Doesn't need to be perfect. But when we talk about question number 28, explain why logistic function is going to work best for this type of data. As you get older, you're going to grow, especially when you're a kid, you grow really fast. But then at a certain time, when you reach adulthood, do you keep growing? You're going to stop growing eventually. And logistic functions, remember, they make this little curve S shape. Logistic functions level off. They're always going to level off. So something like us growing is going to be best represented by a logistic function, not exponential, because we're not going to continue to grow and grow and grow. We're eventually going to stop growing. And that's what logistic functions do. They cap off at a certain level. They plateau off a certain level. Yeah, so plateau or level off, those are terms that you could use. They're always going to level off at a certain height or a certain spot place. So that's why logistic is best for that. For number 29, how to write that. I know we didn't do this a lot, and so I will help you guys write this. You're not going to really need to do this on the test. You're going to just need to know how to read the equation. But let me show you how to write it. I like to just put the big fraction line there for 29. A is on the top. A is 74.7. It says round to the nearest tenth. So I'll do 74.7 on the top. Now on the bottom, you can see there's this 1 plus. So you're actually going to write 1 plus. And the B value is 1.5. So 1.5. Now E you're actually going to write. Remember, E is not a variable, it's a constant. So 1.5 E, and it says to the power of tx. T is negative 0.2 if you round it. And you're just going to put the x. So that's how you write the logistic equation. That equation gives you the line that I've already posted right there. Okay. Now, on number 30, as far as that question goes, according to the model, how tall should males in the U.S. grow to? You're not going to do any math. You're not going to actually calculate anything for this. You just need to know where to look in the equation. Say that again? Why is the logistic function best? Because at a certain point we're only going to stop growing. We can only grow so high. So this line that I drew, remember on a logistic graph, this is called either the carrying capacity, the maximum amount, or it's also on the graph, it's an asymptote. The graph's never going to cross that asymptote. So that line right there is the maximum for this particular graph. In this particular graph, that means that's the maximum height. Okay. Well, how do I figure out what that line is? Without eyeballing it, I don't need to eyeball it because this A value is always the asymptote. Okay, so that's always that maximum value. So for question number 30, how tall should the males in the US grow? 74.7 inches. This right here should be the highest that they grow because that's going to be the highest point on the graph. That's going to be the highest value. That's our asymptote. So for question number 30, that's the answer, 74.7. 74.7 inches, the highest. Okay, so don't have to do any math. You just need to know where to look on the equation. Good? All right. Let's go ahead and do the last one. Let's knock it out. The last one shows about natural gas. You guys know how those of you that live in a house or even an apartment, what is natural gas power? There's three main things that it could power in your house. What are they? The what? It's oven and a stove, your heater, and the water heater. Okay, so generally we use more gas in what season? In the winter. We're running the heater more. Gas bill goes up, electric bill goes down. But actually, the gas bill only goes up a little bit more because gas is way cheaper than electricity. This is modeling how much the month out of the year and how much gas is being consumed and used during the year. So here's our last one. Let's knock this out, and you'll have almost all of the answers to the review. So there's your answer for number 31, little sketch. So why is the sine function best for this? It's a repeating cycle. This is January here on the left side. This is December on the right side. We use more gas in the winter as it gets lower through the year. In the summer, we use less gas, and then when we get back to the winter, we use more gas again. And it's going to continue going up and down and up and down. It's going to repeat that cycle over and over again because of that nature. And that's a sine function, a periodic function is going to work the best, which is that last equation down here on the bottom left. And if we turn that on, we can see that it fits it pretty well. It's pretty, my computer's lagging, but it's going to fit it pretty well. As far as writing the equation, so for number 33, so you should put all the letters together. The format is right there. Should be pretty straightforward, but I'll help you write it here as well. It says round to the nearest tenth, so just one decimal place. 10.3 sine. Now there's double parentheses. I like to use brackets for the outer parentheses, but you don't have to. You can still just use double parentheses if you want. Doesn't really matter. 0.5 x. So here's where you just got to be careful. It says it's x minus c, but c is already negative. So it's like x minus negative 2.3. What happens when you minus a negative? It changes to a positive. So instead of saying x minus negative 2.3, just change it to x plus 2.3. So you don't have a double negative. Close out your double parentheses or your bracket, and then plus 12.8 at the very end. So there's your equation for number 33. So on the last two here, you don't have to do any math. You just have to remember about these parts of the sine equation that we went over last week. On number 34, it says, what is the average gas consumption over the 1 year period? Well, on this sine equation, the average is always going to fall right here in the middle. It's halfway between the minimum and the maximum. How do I know what this average is with that line? That line's the axis of symmetry. Where does the axis of symmetry show up on the equation? Not A. It's always D. D is always the axis of symmetry. So if you know that D is always the axis of symmetry, and if you also know that D is the last number on the equation, then 12.8 has to be the average gas consumption throughout the year. So the answer to number 34 is 12.8. The answer is just right there in the equation. So that's the answer to number 34. And then 35 asks for the minimum and maximum. So the minimum is down here, right? The maximum is up here. If I want to find the minimum or maximum using the equation, remember, if this is D, how do I find, if this is the minimum, what is this called again? This is the amplitude, which is A. So how do I find what the minimum is? I take D to minus A, and that gives me the minimum. Y'all will have to figure that out. A is right here. So you just subtract those two to find the minimum gas consumption. This is also A. So how do I find the maximum? D plus A to get the maximum. So all you gotta do is know that you subtract them to find the minimum, add them to find the maximum, and even if you don't have the graph in to eyeball it, you can always find the answer. Very little math involved there. So you just gotta remember to know where to look for. Cool. We knocked out all of the stuff on the back page. All you have is the study guide stuff left over.